Hello, let's continue our Sudoku adventure with Peaches and Pears by Matt Tressel. So this continues our theme week where we're doing entropic-like lines. So far they've all been modular lines, but today is different. We have 7-tropy lines. Pretty fun. All right, so let's go over the rules. We have irregular 6x6 Sudoku rules. So in each row, each column, and each of these bold outline regions, which are of somewhat random shapes, have to have the digits 1 to 6 exactly once each. We also have these 7-tropy lines in the grid. Every set of 3 adjacent digits have to have one of each, one digit from each group. And the groups are how you sum to 7 in 2 digits. So 1, 6, 2, 5, 3, 4. So for example, if this was a 6, then within these 3, I can't have another 1 or 6 because I've used up the 1, 6 group. But I still have the 2, 5 group and the 3, 4 group. So maybe this could be a 3 that uses up the 3, 4 group. And then this could be a 5. Order doesn't matter, but this would satisfy. This could also be a 2. This could be a 1. This could be a 4. Right? We could even swap these. What matters is within these 3 cells that are adjacent on the line, we have 1 from each group. But do keep in mind that this is also a group. This is also a set of 3. This is also a set of 3. They all need to have that property. All right, and we do have little killers. These are these clues outside the grid with a diagonal arrow. You look at what cells the diagonal arrow is pointing at all the way to the other end of the grid. So these 3 in this case, and those need to add to 7. What a surprise. Lots of 7s. All right. And there is no additional non-repeat rule on any of this. Like the only non-repeat rule in the entire puzzle is the irregular Sudoku rules. We don't add any extra ones. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. How shall I get started? So there's a lot of different things I might want to start with. The first thing would be irregular logic. So for example, I could color this cell and this cell because I know that they're the same digit as each other. Because where does this cell go in this column? It can't repeat in its region, but the column needs that digit. So it's going to go there. Similarly, we know this is not green. So we'll call it purple, and it has to go there. And then, let's see. We know these 2 go here. Okay, so these 2 go here. Now, I don't know if one of them's green or not. I wonder if that's important. Maybe there's more obvious things to look at. This is a little bit interesting. We can call that blue. We don't know if it's green. It could be green. But if we just look, it sees these cells in this region. Yeah, it's not that exciting. Okay. But I'm interested in these 2. Like if we just call this red and yellow, not knowing if we know they're not purple because they share a purple. They share a beige and purple. But one of these could be green, so we have to keep that in mind. But where do they go in this column? Because they can't repeat in the region. And so we need a yellow and a red here, and the red can't repeat in the row. So this is yellow and this is red. I could get rid of green and just ignore this relationship. And then I don't have the problem of one of these could be green. But what does this do for me? I guess is kind of the best question to ask. So in this region, we need a red. They're not here. So this region's going to have a red somewhere in here. And then the region needs this region needs a yellow. That's way better. So none of these can be yellow. So this is our yellow. So we know yellow and red are different and 7-tropies. 7-tropies? That sounds nice. There's another kind of... So what I was going to get at is there's another kind of coloring that's useful, just to color the groups instead of individual digits. So we know this is the same group as green, for example. Which means this is the same group as green. So okay, and they can't be green. So we can name this let's see, what is this? Okay, wait, we actually proven that, oh wait, we haven't proven that green isn't these. But this digit, let me explain what I'm talking about, but let me color it first. Let me just pick blue. So this group of, I normally color these, but let's just talk about this group. Let's talk about this group of 3 here. It's got a green, and then it's got the green, whatever group green is in, and it's got these 2 groups, which aren't that one. And now these 3 then need a digit from the green group, and we know it's not these 2 because this told us that. So you get this kind of cyclical nature on these lines where this is going to repeat again 3 away. So this repeats 3 away, this repeats 3 away. The group, not the digit. And so this is the other digit in that group because they share a column. And so this group of 3 needs something from the blue-green group. In fact, what I can do is use a palette where, like, we know these are the same group. So I'm going to replace this green with another green that's from this palette. And I'm going to use a different green here, like a lighter green. It's a little bit hard to scan that, but we'll see how that goes. So this is I wonder if this darker green, yeah, so we got the dark green and the light green. So we know they're the green group, but, and so we know these are the same digit and these are the same digit. I'm going to try this today. So, because this needs something from the green group and it can't go here because both greens are gone. So this is from the green group and it can't be the dark green, so it has to be the light green. Okay. So that's what we're going to do when we find out what groups that are the same. Now, what I was saying is we know that this light green can't be purple and it can't be red or yellow because of the rows here. And we know it's not dark green. So we know it's a unique digit from all our colors. The problem is dark green could easily be red or yellow. So we need to be careful about that. Oh, wait. Yeah. Oh, actually, it is yellow. No, it's not. Sorry, I misread that. These 2 are from the same group, and they're not the green group. So, we know it's not. We know that we can't have another green on here. In fact, you see these 2 greens looking up. So, no, this is involved in every group of 3. The only one that aren't is these 2. These 2 are the same group. And so let's actually give the yellow a different color here because we know it's not the green group. So let's call it the blue group. We'll make that dark blue. Now we don't know where light blue goes. That's in the same group as it, but we could look at this line here. So hold on. Can this be the green group? I think red could be dark green. But where does this repeat? It repeats here. And that's in the same region as it's in the same row even as a dark blue. So it has to be a light blue. So 3 away, and then, yeah, we're done. So whatever's in red, actually, what goes with this red is going to go here, but it could just be red again. So we know purple's not either of these guys. We know this is the other purple. Purple's not light green. This one's not dark green. I don't know. Maybe there's some irregular geometry I haven't noticed yet. Okay, I don't know if red is going to be dark green or not. I'm starting to suspect it is, but I don't know that for sure. We have 3 more colors here. Do we need a purple? The thing is, purple could be light blue. For all I know. Okay. Gotta be really careful about my coloring here. It's not doing great, is it? Oh, this is light blue, because these are the same group. And so this is whatever I'm going to call the other group. I guess it's going to be this brown, like this brown color, or the reddish group. Which means I probably shouldn't use red for this. But I can tell the difference. Yeah, let's not use red here, actually. Let's pick let's pick yellow, which isn't going to be one of my groups. Okay. So we've got the red group, the green group, and the blue group, and then we have a dark and a light for each. So this column is looking pretty busy. It needs a light blue and it needs a light red. So what do we know about that? Oh, this row has almost everything. So we can ignore the yellow, but yeah, it needs a dark green and it needs a light red. Huh. Well, this can't be dark red. It needs a dark green and a light red. Which is which? This repeats here. These are the... Okay, so this is one of each. This is a light and a dark. For what color? Whatever's not purple, I guess. We know this is one of each. So these are also one of each, right? One of each, one of each. These are one of each, a light and a dark. So we know this isn't the blue because this one sees both blues. This one sees both greens. So yeah, I guess let's start from the beginning here. These are 3 away, right? Or if we count 1, 2, 3, the cyclical nature means that these are both from the same group on this line. Same cyclical nature tells us these are from the same group. In fact, it's the same shape, right? This just gets extended. So these are from a group, these are from a group, which leaves only one group left. These are the 2 digits from a group. Now, can that be blue? Well, no, because this one can't be either blue. Can it be green? Well, no, because this one can't be the dark green by the row or a light green by the region. So if it's not blue or green, then it's my red color. So we know that it's the red group, which means this cannot be light red, which means our yellow is light red. Very nice. This is our light red because the row needs a light red. And then this is our dark green. And now this can't be light red because it shares a row with light red. Oops. Can't be light red. There we go. And so now this is dark red. Oh my gosh. Okay. Getting there. I'm forgetting what colors I'm using for things. But anyway. So this is the light green. Am I using the right ones? This is the light green. And that means purples are the blues. So purple is one of each blue. Unfortunately, I can't tell which blue, but we can at least... Let's just mark all 3 of these as the blues. So this needs to be... Well, we need a green and we need a red. So we need a dark green. Sorry, we need a dark red here because of the column. It already has a light red. So we need a dark red. And then we also need one of the greens. Oh, but this can't be dark red. So this is our dark red. And then this is one of the greens. It's not light green, so it's dark green. Okay, perfect. So this, I feel like dark greens are getting close. We need a dark green in this row. This says not here. This says not here. This says not here, right? So this is our dark green. And then we need a dark green in this row, which has to go there. This says not there. And we can just finish with a light green here. Okay. So this column has both greens, both reds. It needs a light blue. This light blue does not distinguish these. I need a dark red in this column that goes here. And now we finish with a light green. And then... What's next? There should be something simple, I would assume. Here we need a light red and a light blue. Well, this can't be blue at all. This sees both blues. So this is our light blue, and that leaves light red here. So this has to be light green to finish the row. So here we need a light red and we need a dark blue. So this is light red and dark blue, which means we need a dark red in this column, which goes there. I think we can finish the dark reds. Why doesn't this column have a dark red? Hold on. What did I double? There's 2 dark reds in this region. Oh no. Oh, does that just mean this is light red? Oh, I don't know if I used this. Shoot. Oh, did I just fill that in? I just filled that in. Okay. We need a dark red in this column, but there's nowhere to put it that works. This region needs a light red, but I feel like I already have a mistake here, because this column doesn't get a dark red. Oh, I have 2 dark reds in this column. One of them was supposed to be light red. Oh, this one's light red. No, sorry. This one's light red. Oh, okay. Yes, that works then. And this is light red. Okay, perfect. Now, oh yeah, we need a dark red. It's not there. So that's a dark red, and then that's a dark red. Okay, I just miscolored something. There we go. I fixed it. This row needs a dark blue. Hopefully I didn't do any invalid logic. Probably not. This needs to be dark blue as well for the column, and then this is a light red. Okay, hopefully, I mean, there's no conflict check on colors. Oh, and this is not dark blue, so this is not light blue. This is not dark blue. Okay. No conflict check on colors, but it looks okay to me. And so we aren't done, though. We need digits. So we know these add to 7, and it's got a repeated digit here. These are both dark blue. So these share a region, and they aren't dark blue. So, I mean, I guess the first observation is dark blue cannot be a repeated 3 or higher. It's definitely a 1 or a 2, just through obviousness, right? 2 plus 2 is already, sorry, 3 plus 3 is already 6, and we have 2 more to add to 7. So they're definitely 1 or 2 for the dark blue. Now, that means we need one of these to be a 3, because we need, I mean, it's not going to be a 4. 4 is too big, I think. Well, one of these needs to be a 3 or a 4. The other one, so what the minimum is, the minimum would be to use a 3, because we need one of these to be from the group that has 3, 4 in it. So one of these is a 3, and then the other one could be a 1. The other one could be a 2. So 3 plus 2 is 5, and then this could be double 1. If we did 3 plus 1 is 4, then this would have to be double 2, and that's too big. That would be 8. So this has to be a 2-3 pair, and then the dark blue is actually 1, meaning the light blue is actually 6. Okay, great. Now we know that dark green is not 1, which means this can't be double 3 to add to this 7. So this has to be double 2. So all the dark red is 2, and all the light red is 5. And now all the dark green is 3, and all the light green is 4, and we solved the puzzle. Nice. We get a 3 in the corner there, celebrating. That looks pretty. I actually kind of like using that palette. Nice. I really hope that mistake didn't cause any problems. But anyway, let me know how you did. And oh, by the way, Matt, I really like this puzzle. This was neat. It's your classic color everything, and then, by the way, these little killers tell you what all the digits are because we have to fill digits. But the puzzle's basically over once you've colored everything. It's kind of interesting. Anyway, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.